Record.
Yep, we are going now. Yep.
Great. So welcome everybody to the final online session before we meet in person in just a few days. So I have a fairly substantial announcement for everybody, and I will follow up with an email. But this is permaculture principles in action, creatively use and respond to change. The problem is the solution. We have had to change the venue for the permaculture design course. There has been some rumblings from neighbors just around what Ginger and Rob have been setting up on Basalt Mountain. And rather than being shut down potentially halfway through the course and that being very disruptive to everybody, we've decided to just go ahead and change the location from the get-go so that there's no disruption. Problem is the solution. We are going to hold the venue at Sustainable Settings Ranch, which is where we had it last year. Rave reviews from the students last year in terms of a setting for a permaculture design course. So rest assured that the place that we're going to have it is going to be awesome. There's a beautiful outdoor kitchen. It's a biodynamic ranch. It's in Carbondale. So in a way, it's somewhat more convenient in terms of access, both to getting to Carbondale, and you know, picking up anything that you need there. And then CRMPI is about 20 miles away. So we will still be visiting Basalt Mountain Gardens. We will be going to CRMPI obviously for a tour and doing some hands-on stuff there, but we will be at Sustainable Settings. And so I will send you directions. In this way, it's also very much simpler. There's no shuttling that's going to have to go on. You'll just drive directly there. And there's plenty of space, both in a small field and in other areas of Sustainable Settings, since it's a 244-acre ranch, to set up camping. So it's a really great solution. Megan was there last year. It's a lovely spot, and people and students last year just really loved it there. So we apologize for the last minute change. I know it's a little disruptive, but it's better to have it happen now than halfway through the course.
There's also plenty of parking, so everybody will be able to have your car with you, and great showers and great people. Honestly, I think you'll be more comfortable this way. It's a wonderful place to be.
Yeah. Are you going to email the address?
Absolutely, of course. Yeah, so I will follow up. Tomorrow morning, I'm going to follow up with last minute, the directions to Sustainable Settings, and then last minute stuff. Again, you're not going to have to, we're just going to ask you to show up after 3 p.m. on Sunday. So there will not have to be kind of timing in terms of shuttles or all of that kind of stuff. So in a lot of ways, it's a lot more convenient and easy. So any questions related to that venue change? And then other logistics like last session, we'll just hold off on those until after Adrian is done his session. But any questions with regards to that?
More of a comment. So I'm taking a bus that's going to just land me in Basalt sometime that I feel like it, and that was going to be timely. It looks like I was going to either walk, but if I have to pay for a cab, I'd rather pay somebody if they have a ride. So somebody can just hit me up or something like that if they want a little bit of money and gas money to bring me from like downtown Basalt to wherever this place is. I'm just going to throw that out there.
Great, Scott. And maybe Adrian, you can speak to this just in terms of can Scott just get dropped off in Carbondale instead of Basalt?
Probably, yeah, because you'll be coming that direction. What is it, a Mustang, or what is the venue? Rafta?
I'm coming from Aspen. It was easier for me to fly into Aspen, even though I'm in Colorado Springs.
Yeah. So you're taking Rafta down. Yeah, it's like 2 more stops down in Carbondale, and I'd be glad to give you a ride if you tell me when you'll be there.
Awesome. Well, we will coordinate separately then. Thank you.
Cool.
So yeah, Scott, I'll give you Adrian's contact info. If you don't hear from me, feel free to just email me and I'll just as a reminder.
Awesome. Perfect. Thank you.
Cool. Awesome. Any other questions as it relates to the venue? Cool. Great. All right, Adrian, take it away.
Excellent. So I watched a little bit of that video recording, and I think you might have seen about half of the images that I was trying to show you. The bandwidth and the lag was really bad. So I am doing away with Wi-Fi. I'm at my work here. I'm plugged directly into the Ethernet. This is going to be great. But a couple of other things that'll help will be if you turn your video off. We will have a couple of more interactive parts, but we won't need to have video on. So I'm going to turn mine off too, because the actual screen that I have to look at is over here. So that'll cut down on some dissonance. So I'm going to go ahead and do that now, and we'll get started. Please do mute yourself as well. That will help the audio come across. So. All righty, here we go. Can you see the slideshow?
Yes.
Is it showing the next one as well?
It's showing the notes on the side.
Notes on the side, okay. Well, there are no notes over there, so that should be just fine. All right.
Although it's the image is kind of pushed over to the left.
Okay.
So if there's a way.
So it's not, you can't see the entire, there should be a big picture here with water and earthworks in the middle.
Yeah, so it's kind of offset to the left a little bit, so we can't see the whole photo.
That is a problem. I do not want it to be like that. Oh my goodness, you have got to be kidding me. I am working on someone else's laptop, and it's like trying to cook in somebody else's kitchen. It's absolutely ridiculous. How about now?
And now we can see, we see both images, the water and earthworks, and then the no notes. But
okay,
that'll
perfect. Work. All right, this is way better. All right, so this talk is about water and earthworks. Earthworks are when we shape earth and rock to accomplish certain functions in the landscape, such as roads or house foundations or foundations for any structure, so that we can access our site and have a place to live when we get there. But tonight we're going to focus specifically on earthworks that allow us to make the best use of water, because there are many of those. And to help us get started, can anybody out there remember what I said on Tuesday about what our job is as permaculture designers? If so, come off mute.
Smart design.
Good. What else do you remember?
Observe natural patterns expressed by energy and resources.
Hugely important. Yes, thank you. And what is the goal? Like, what is our end result that we're trying to do with our smart design and our working within patterns? All right, I will give you the answer, because this is real important. This is the whole point of us being together and doing this stuff. Our job is to co-create the conditions for life to emerge and complexify into forms that are truly durable. That's it. We are assembling systems that are all about life. So water is probably the most important element we work with for a few reasons. First, it has the most constants in its behaviors, which allows us to make plans with it with some degree of certainty about it showing up eventually. It's not a flaky friend who never shows up on you. And if we're ready for it when it does show up, that is, if we've prepared to receive its flow in a manner that will maximize the functions we need it to perform, then we can receive its blessings to benefit to our system rather than to its detriment. So water is a powerful force that can destroy if we do not respect it. So the picture here that I'm showing you on the left is of a place near and dear to my heart. And I found it in an essay by Craig Childs called Heart-Shaped River about that very place, which is called Canyonlands. So this is where the Green River joins the Colorado River in a landscape that's really just so terrible in its beauty that it's impossible to describe. If you've been there, you know what I'm talking about. But if not, I bet you've seen a similarly stark desert environment where your first thought is, you know, how does anyone live in a place with so little water? Well, in fact, the desert is a place where water reigns supreme. For all those canyons and bluffs have been shaped by water and a bit of sand blowing in the wind over the eons. But by the way, Craig Childs is one of my favorite authors. And he's trained as an alluvial geomorphologist. That is someone who studies how streams literally carve out landforms. So water's powerful. It has the ability to carve out these beautiful landscapes like all of Colorado and this place in Utah. I recommend all of his books, but in particular on the subject of water, I recommend The Secret Knowledge of Water, as well as The Desert Cries, and of course, House of Rain, which is probably his most famous one about the ancestral Puebloans that some people call Anasazi. So besides being able to shape the earth, which is a really powerful thing, water has amazing properties that can perform a huge number of duties for our permaculture system. So here's another fishing expedition. Who remembers the property of water that we discussed on Tuesday? Anybody? This is part of why it's so powerful.
It's an edge.
Yeah, that's right. It's the ultimate edge in nature, right? Because it allows all these other things, these different forms, different organisms, different substances to come together and create new things, right? Without liquid water, there would have been no life on Earth. We know this. So along with that property, and largely because of it, water gives us the most life enhancement, which means it's our number one tool in accomplishing our job, which is what again? Co-creating the conditions for
life to thrive.
Yeah, that's right. So as the Lakota saying reminds us, Miniwinkoni, water is life. So let us acknowledge that none of us would be here if it weren't for this land that CRMPI calls home. And this is land that was stolen by the US government a mere century and a half ago from indigenous people who cared for it for many thousands of years as the living body of their mother. These people are collectively known as the ancestral Puebloans of the Colorado Plateau, which you see more or less represented here within the red circle. And they lived a transhuman lifestyle. So they would spend the winters down in the western part of that red area where it's desert and a little bit warmer, and you don't have huge blizzards that occur during the winter. And then as the summer would arrive, they would move up into the mountains of Colorado over there on the eastern side of that area. So most recently, this included the Nooch, the Paria Nooch, and the Yapatika tribes of the Ute Nation who were forcibly removed from the land over a period of about 4 decades, from the 1880s to the 1920s is when it was pretty much done. So the Southern Ute and the Northern Mountain Ute are presently the only 2 federally recognized indigenous groups in Colorado, even though the state is home to people who are descendants of many different indigenous nations, as well as people whose ancestors migrated here from distant countries where their ancestors were also indigenous. Sometimes they moved here of their own free will, and sometimes against their will. The same is true of the entirety of North America, the land that many people call Turtle Island. You see those tessellations on Turtle's shell? So let us receive a prayer of hope for us to bless this precious learning opportunity that we have together, and to ground it in our shared home, or if you're visiting, our shared place of visitation, because we're all just visiting. By hearing Katrina Blair, one of my teachers, sing to the Crystal River that's right here in Colorado and goes right by Sustainable Settings, where you will be staying.
Thank you, water.
No
I
audio
love
here.
you, water. I'm so grateful for you. Water. Thank you, water. I love you, water.
You can't hear audio either,
I'm
can you?
so grateful for you, water.
Well, the best laid plans of mice and
You
men.
are
It's a
the
beautiful
rain
song. I'm not going to try to
falling
sing it.
down. You
But
are
she
the
thanks water.
river flowing over ground.
Thank
Hear it,
you.
You
Adrian. I
are
can hear
the
it.
ocean.
Oh, great. I'll stop talking now.
Sweet big body water, mama of ocean. May you be wild, may you be free. Oh, you are one with me.
Okay. So with that, long life, honey in the heart, and 13 thank yous for all that is and all that will be. So it is. In this lesson, you're going to do the following things. You're going to develop a greater fascination with and reverence for water, which is the most abundant molecule in the universe. I'll repeat that. You might not have known that. I didn't know it until I was a grown person just a few years ago. Notice I'm saying molecule and not atom, right? Because water is not an element in the sense of the chemical chart of elements. It is a molecule that has hydrogen and oxygen combining together, but it is the most abundant molecule in the universe. So let's not get too scarcity minded here. There's a lot of it out there, but I do want to scare you a little bit as well. So, and that's because I want you to learn a variety of design strategies for harvesting water, storing it and reusing it, and really maximizing its efficiency, which is sometimes called conserving water. And that's not the same thing as not using it, right? And even using water for other things like thermal mass, which can increase your energy efficiency. So we're going to look at a few different designs for doing that. And the other thing I want you to learn how to do is to slow it down and spread it out so it can seep into our landscapes. Now, I do have a caveat here, which is, remembering our permaculture ethics of earth care and people care and fair share, we really need to consider the impacts always of our water harvesting activities. and what effects they have on our downstream neighbors, both human and non-human. Not all permaculture techniques are applicable or appropriate in every location, climate, or scale. So we want you to have a well-provisioned toolkit of possible techniques that will enable you to thoughtfully address issues in each location that you may be designing for. So this image gives us a stark reminder of why this is important. You see those two water droplets on the back of the turtle. The bigger of the two represents to scale what it would look like if all the water on Earth, including the oceans, were to be gathered up into one drop. It would be about that big compared to the Earth. The smaller of the two shows how much of that water is fresh water rather than salt or brackish water. So this data I'm showing you is already 3 decades out of date, but it already shows how dire the situation is. And it's gotten worse since then. So these bar graphs are not to scale vis-a-vis each other, like the droplets are. For the two on the left are the same as our 2 water droplets, right? The one on the left is all global water, and the middle one is freshwater only. Notice how only the very tippy top of the middle graph is available on the surface. The rest is either frozen or underground. So when we talk about watersheds, most of that water is comprised of that surface water that's on the very top and some of the groundwater portion as well. So what is a watershed? It's just a drainage basin where the shape of the land catches the water and sends it into streams and eventually down to the sea. I'm going to try a little annotation here so you can see what I'm looking at. So here are our watersheds in Colorado. The 3 over here, these 3 on the eastern side, they're on the eastern side of the Continental Divide, so they all empty into the Gulf of Mexico via the watersheds we can see here, via the Mississippi River watershed here, and then the Rio Grande, which is blue. But these 4 over here on the western side of the Continental Divide become part of this larger yellow area right here. That is the entirety of the Colorado River, which used to get to the Pacific Ocean via the Bay of California, or the Gulf of California. But it no longer does so. You might have heard this, because all these states around here use up its water before it has a chance to get to the sea. So this down here used to be a beautiful river delta, just thriving with life, right in the middle of the desert. But it's now really, pretty much a no man's land, since the water from the river is busy making golf courses green and growing the lettuce and the almonds and other things that most Americans buy in the store, which are produced up here in the California Imperial Valley. I personally love how this image shows us a completely different map than we're used to seeing. What if our consciousness also saw the landscape through this lens? If we zoom out, we can see the world's major watersheds. Now, it may have been a minute since some of you had 5th grade science, whereas some of you may already be watershed scientists, for all I know. We'll get to know you better during the course. And if so, please indulge me for one more minute as I asked Jeff Lawton to refresh us all about the global water cycle.
The global water cycle of land and sea is a broad schematic of the water cycle. We can affect all parts of this cycle in adverse or beneficial ways. Evaporation, transpiration are the main elements that make up atmospheric water. 84% is evaporated off the sea. 16% is evaporated off surface storages and biological storages. 23% falls as precipitation and is intercepted by forest canopies, surface storages, and the global water cycle.
Oh boy. Sorry about
The global water cycle of land and sea is a broad schematic of
We got absolutely no ability
the water cycle. We can affect all parts of this cycle in adverse or beneficial ways. Evaporation, transpiration are the main elements that make up atmospheric water. 84% is evaporated off the sea. 16% is evaporated off surface storages and biological storages. 23% falls as precipitation and is intercepted by forest canopies, surface storages, and joins overland flows of streams and rivers. Some goes to soil storages, infiltration seepages, and through flow springs. Infiltration seepage goes on to groundwater storages and interflows within subsoil as spring lines. Further still goes on to deep storage recharge, base flows of deep springs. All help recharge stream flows at the surface.
Okay, so I have a question for you. What would happen with the global supply of fresh water if we humans, as a species, partnering perhaps with beavers, were to slow down the process by which precipitation returns to the ocean? If we were able to do that on a global scale, what would happen with the global supply of fresh water?
It would disappear.
No, it would not disappear. It would increase because water from the ocean would continue to evaporate and transpire and then precipitate.
Oh, so they would rain more and then the rain would gather.
Even if it didn't rain more, let's say it rained the same amount or even less, as long as we were able to slow down the process by which that fresh water returned to the ocean enough, we could still increase the amount of fresh water, right?
Oh.
Because it's a cycle.
Wow.
Pretty neat, huh?
That's cool. That's cool.
So beavers are our allies. And in fact, there's an excellent essay by Toby Hemingway, a late permaculture designer, that's all about how beavers are like the ultimate permaculture designer. So if we can learn from them and do the kind of things that they do, then we can really rock it out. So
the global water.
That's some grand scale thinking. P.A. Yeoman was an Australian farmer and engineer who developed the concepts known as keyline design. And I'm going to explain how this works a bit later, but for now, I want to explain his idea of the scales of permanence. So over on the right, you see a graph that shows you how much effort it takes to change each of those keys, and then how much permanence those changes can have if you do change them. So climate is the highest because it takes a huge amount of energy to change the climate. Just think about all of those fossil fuels we've been burning since the Industrial Revolution. That is a huge amount of energy that it has taken to change the climate. Of course, we all know, and I know that you know, that we can do the opposite too. We can create a drawdown economy that brings that carbon out of the atmosphere, puts it in the soil, and we can reverse that. But wow, that's a lot of effort. And it's going to take a while. So that being said, if we're able to make that impact, it'll stick around for a while. And as you probably heard, the carbon in the atmosphere has a global warming effect that lasts several hundred years. So the permanence of these changes is high, but so is the amount of energy it takes to actually change them. Same with the shape of the land, right? How much energy would it take to change the shape of canyon lands? Huge amount. We're not going to try to do that. Water is the first place where we as designers can really start to have a bigger impact, right? It does take energy to do that, right? So creating earthworks is an energy effort. Like it does take some energy. But if we were all able to do it, we could change the global water cycle. But here's the most important idea is that, that Yeoman gave us is that, we can have a big impact on our site, right? So independent of the global water supply, we don't have to try to do that because that's gonna take a huge global effort, but we can actually change water on our site. And then moving down here, we see that we have more and more ability to have an impact, but that impact has a lesser permanence. So as Corinne mentioned last week, we can actually change soil pretty quickly, but it also can get washed away pretty quickly. So, and we need to continually feed it to grow it. So this is a pretty useful way to understand what we're trying to do. So let's start this adventure by looking at some of the simplest ways to make the most of water's life force. And later, we'll see some fancier examples. So I'm going to play you the pot system so you can see what that looks like. This is an indigenous technology, many thousands of years old. I do think I have this on mute. Tell me if that's not the case. So in this system, you need an unglazed clay pot, which you plant in a hole with proportions about yay big. This isn't for large scale planting. For each small scale planting, you would need a separate pot. And if you keep it full of water, it's going to slowly seep that water out into the surrounding soil. And this is actually the most efficient way to water because of how slowly the water seeps out. It gives the soil just the right amount. Here's another way. We call it mulch magic, right? So this is hugely important in dry land, arid environments like we have in Colorado. Now, you may come from a place where you may be able to grow plants without mulch. Forget about it in dry land, okay? So you actually need mulch to do all kinds of things in a dry land environment where evaporation is greater than precipitation. So it does a few things for us. First of all, if it's organic mulch, it breaks down and nutrients are released into the soil. And crucially, it keeps the sunlight out, which minimizes evaporation. So you really can retain the moisture in the soil for longer. With some weed seeds cannot germinate without sun. So it tends to have an effect of suppressing weeds. And then hugely important, it insulates plant roots, protecting them from hot, cold, which we especially get up here in the Roaring Fork Valley. And then on the right, you see what happens if you don't have mulch. All those beneficial effects are reversed, and you start to have eroding soil. So mulch is hugely important as a water retention and water harvesting technique. What can you use for mulch? Yeah, organic material, and that's mainly what you'll see up here. But whatever you have, really, rock mulching was used by the ancestral Puebloans. You go to some of these old sites, they got rocks keeping the moisture in, right? We talked about that as a way of planting raspberries and other plants that have suckers. But yeah, use whatever you got, logs, whatever objects you have and can spare for that purpose. I have some pretty cool pieces of artwork. That's a great way to beautify your garden too. So I wanted to start with these examples just to show how simple it can be to start honoring water's role in our systems. But let's take a step back for a moment into theory to consider a few principles for managing water in permaculture systems. So these come from an amazing designer named Brad Lancaster, whose work I'll show you in a moment. But here we go. Begin with lots of observations, right? Really, ideally, you can live in a site for a year or more before you start making design choices, right? Observe, observe, observe. So make sure you got that observation journal and really, really be paying attention. You want to start at the top, and that'll make more sense a little bit later. But that's because water flows downhill. So you want to start designing with features such as earthworks that can retain water higher in the landscape. You want to start small. Don't try to do it all at once. Don't go with really big things. And most importantly, you're trying to slow the water down as it's trying to leave your site. You're trying to spread it so that it infiltrates the ground. When you do have a catchment, you always want to have an overflow, and you want to be able to use that overflow when it does occur, let's say in a flood event or a big rain event. And you want to be able to use that as a resource. Try to maximize living ground cover. I'm not going to say it's better than mulch. It's just a form of mulch to have actual plants that are growing. But yeah, like clover is great. I use clover all the time in all of my plantings. It's really good at providing those same benefits that mulch does. Here's a big one: stack functions. Whenever you can get more than one function out of an element in your design, go for it. In fact, it's a good challenge that we'll give you later when you're designing, but we'll ask you to find at least 3 or 4 or 5 different functions for each thing that you're putting in. Same with water. Feedback loops. If you notice you got too much or too less, or things aren't working out, pay attention to that and make adjustments. And then this is sort of the same as starting small. Many small earthworks are preferable to a few large ones, right? So this will make more sense as we continue. So here is a method of irrigating that you'll see in action at sustainable settings. Which can be quite useful for watering very large areas.
A simple flag
without
made
much
from a wooden pole wide enough to cross
so all you
an
need
irrigation
is an
channel
irrigation ditch
and be well
with a
supported
considerable
on
flow.
either
You can hear
side
the audio,
with an
Adrian.
attached canvas sheet and a
I don't
reasonably
even know how
heavy
to turn it
chain
off.
sewn onto the opposite
It's
end
like I
can be
can turn it
laid
off
in the channel
when I've got the actual PowerPoint up. But then when I'm showing it to you, on Zoom, it doesn't let me do that. Okay, how about now?
You're no longer sharing your screen.
Oh, right. Okay, that might happen again, so thanks for catching me. Oh gosh, here we are again.
Oh, and now it's now the image is kind of offset.
How did that even work?
There we go.
Okay, perfect. So yeah. Oh, and now I can actually change the volume. This is great. So yeah, this can be useful for large areas, and you don't need a lot of infrastructure. Really, If you got an irrigation ditch with a considerable flow of water and a relatively flat area, not completely flat, below the ditch, really all you need is a bit of canvas sewed around a pole on one end and attached to a relatively heavy chain on the other. This is much less expensive than a huge water gun, and it loses less to evaporation because you're not throwing the water out into the air, into the hot sun. It's just seeping into the ground. So this is called flood irrigation or flag irrigation, because that thing is called a flag. The one downside to this is that you need a large and steady, that is a non-sporadic flow of water, which is not available at every site you may design, right? So I'm going to show you later those techniques where you can capture sporadic events, sporadic water flows. The other problem is generally the water is unrecoverable for use on site, unless you just happen to have a basin aquifer that's catching the groundwater and holding it in place, and you have a well that can tap into that groundwater. So in Colorado, there's a strange system of water law that creates perverse incentives to use all the water you have a right to use, even if you don't need it all, because other people can actually put a claim on any water you're not using. But most places in the West have the opposite problem, which is that of not having enough water. So here, permaculture is perhaps best known for its water harvesting technologies that are suitable for dry land environments, due to the astounding successes of permaculture projects in a lot of deserts and in arid climates, which are able to obtain a high yield with low water inputs. So you might have seen my teacher, Jeff Lawton's work in Lebanon and the Los Plateau in China, which were featured in a great video by John D. Liu called Regreening the Desert. Definitely check that one out. Another more recent example is the work of Brad Lancaster, who has revolutionized the way the entire city of Tucson manages stormwater through water harvesting. So this is his famous TED Talk video, but I'm actually going to show you some images from his book, Harvesting Rainwater, along with a few others that I've gathered over the years to show you how simple but powerful these passive designs can be. So this here is the dominant paradigm for how stormwater is managed throughout the industrialized countries around the world. Brad calls it a path to scarcity, and especially in a desert environment, it's completely backwards, because it's all about getting rid of the water as fast as possible, which just scours and creates more erosion and doesn't allow that water to do what it's supposed to do. But this is what we're going for. This is the path to abundance. You see how it's exactly the opposite? We want to gather the water into little pockets sunken below the concrete. So you see that curb cut right there? That's the technique Brad has made famous. Now, Portland is not an arid area, so let's see how it plays out in dryland situations. This is a sunken basin. You see how the tree is planted in a recessed area that's shaped a little bit like a bowl. Now, this is good when the land is relatively flat, but you know from observation that it will gather in a specific place. So this is why observation is so important. Go out in big storms, walk in the rain, note where the puddles form. Those places would be where you might place a sunken basin. Similar to that is an infiltration basin, where there is some slope that can carry some of the water downhill. This one is placed just below a roof gutter and shaped so that some of it will seep into the ground on the higher end, while some of it will be carried down to the lower part of the planting area. Here's what that same place looked like after capturing a few storms and snowmelt cycles. This is with no irrigation. Y'all can see the after shot? here, 2 years, 4 years. You can see that. I'm assuming so. Let me know otherwise. So here's the before shot of Brad's home in Tucson. And again, with absolutely no irrigation in a place that I think gets less than 10 inches of rain a year. This is what it looked like after 10 years. And then after 15. So all the energy Brad had to put into the system on the front end, and then basically just sit back and wait. So here's a close up of a curb cut, and he made all the ones at his residence without permission from the city. And he brought in this machine to make them. He did get in trouble with the city that fined him and threatened even worse, but he hung in there. He went to meetings, explained his reasoning to the city and the neighbors, and eventually they could see the results themselves, and they ended up adopting the strategy of curb cuts for citywide designing for water, or as he calls it planting rain. So when you're designing a system for passive collection of precipitation or runoff, you need to know how to estimate how much water you can harvest in your site so that you can compare it with how much water you need. And to that end, we're actually going to send you another worksheet with a one-page cheat sheet for calculating runoff in a catchment area, whether that be a roof, a road, or a field. So hold on to this worksheet and use it toward the end of the course when we get you designing for an actual site. So you can check out Brad's videos on his YouTube channel. But next, I want to show you some more designs for water harvesting. But first, before that even, are there any questions before we proceed? I know that's been a lot of information so far. So any questions out there that I can answer for you?
Hello, can you hear me?
Yes, sir.
Quick question. I thought there was some kind of old school laws in Colorado about rainwater harvesting. Has that changed recently, or?
Just a little bit, yeah. Colorado really is the most difficult place, I think, to do this kind of design. That being said, some things are illegal and other things are not. So most of the things I'm going to show you are not illegal, even in Colorado. So passive water catchments that's happening, they don't even, the powers that be, they don't even really see that. They don't even think of it as an issue because they don't understand how much water you really can collect in the ground. The main thing they're worried about are like actual like above ground catchments like dams or even cisterns. Like you have to have water rights to use the water if you're going to collect it like that in a cistern. But recently, one of our permaculture friends named Avery Ellis created groundswell that resulted in a change to the state law that allows residents to have 2 55-gallon barrels to catch water off the roof. But that's all you're allowed, which is a really small amount, but you can do that. Great question. Colorado is really an outlier when it comes to water law because it is old school. It's like it's cowboys and Indians, and it's real serious as far as like when they say in the West, whiskey's for drinking and water is for fighting, they mean Colorado especially. Now contrast that with New Mexico, where there are amazing systems of collectively using water called acequias, which are really cool. It's like socialism for water, but Colorado is exactly the opposite. Great question. All right, we'll have some more time for questions at the end. Let us hope that I did not lose the good. Okay, can you see the image again? Hopefully.
Yes.
Okay. In a couple of minutes, I'm going to share some of the other all-star permaculture techniques for harvesting intermittent precipitation and water flows. And those can be used for irrigating plants or drinking water for animals and people. But first, I want to change gears and discuss some of its other uses for permaculture design. So come off mute if you can think, what are some other uses for water?
It could be an energy source, whether through hydro or even a pumped hydro system if you have the money.
Great. Yeah. And this is one of the reasons you want to start at the top, because when you've got water at the top, you can do all kinds of really interesting things to actually produce electricity on your site. Yeah, a lot of, you could describe a water catchment high in the landscape as a battery. It's literally holding energy within it, especially if you have at least 100 feet of elevation change. So if you're looking for a site, keep that in mind. That is a really key data point for you to have in mind, because you can have energy independence through various techniques. And if you've got 100 feet of elevation change or more, then that's when you really start to make an impact on your energy self-reliance. Great. What else?
You can use it to store heat.
Absolutely. And more specifically, you can use it as thermal mass, which is not exactly the same thing as storing heat. So water is a very efficient form of thermal mass, and that's useful for both cold and hot climates. In cold climates, water stored in a container located in full sun can absorb the solar radiation during the day and then release that heat at night when you need it in your home or your greenhouse. So I was telling a small group on Tuesday that in our greenhouse at my campus, we have a water tank. It's about 500 gallons, and we painted it black so that it would really gather that solar radiation during the winter. Try to moderate the temperature in that greenhouse. Also keeps algae from growing in there. But the opposite is also true. This is a crazy thing about thermal mass. So in hot climates, keeping water well shaded and well ventilated allows it to lower the temperature in the surrounding area. So it'll release heat at night, and then the water pulls heat from the hot daytime air and from nearby structures, which produces a cooling effect. Pretty neat, huh? What else?
Recreation.
Yeah, baby. Swimming, stand-up paddleboarding. Love it. And that's a great way to cool down too. Ooh, that's my favorite way to cool down. Just dive in. It's going to be hot when y'all are here. And that irrigation ditch, those irrigation ditches at Susty are going to be calling your name. As is the river, which is very close. What else?
Maybe for fish?
Yeah, aquaculture is a wonderful, just hugely productive form of agriculture. You can grow fish or plants, and in fact, the most like highest selling crop by weight is a green plant that grows in water that is basically only eaten in Asia. I forget the name at the moment. If anybody knows that, speak up. But it only grows in water, and you can actually produce enough protein for a village, depending on the size of your system. So beautiful. Anything else? You can use that that pressure when you have the water stored high to do all kinds of things in your house, right? Flush toilets, run showers, clean. This is a pretty good start. I think we could probably keep going, but this is just fine for now. For some reason, I cannot advance. Okay. All righty. I'm gonna let Jeff explain this to you.
Water storage and uses. This shows the layout for a small farm. It is just a schematic of gravity flow systems in relationship to farm buildings, dams, ponds, and roof water tanks, as well as placement of high dam pond within extra catchment input as an inlet from higher water catchment or source, with a spillway to another dam pond. Fitted with a siphon pipe intake to gravity feed water downhill, this water will irrigate gardens, feed stock drinking troughs with ball valves, and can be used to flush toilets if needed. Also positioned high in the landscape, barns